The two types of errors which we encounter when deciding the sample size is the confidence interval and the confidence level. If you had interviewed 54% of the population, or if you had interviewed 66% of the population, they also would have given the same answer what you would have expected. Now, what is standard deviation? Standard deviation will tell us the deviations from the mean. So, how far the given data is from the mean. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 3 of Unit 4, let us have a discussion on sample size determination. Now, in the previous sessions, I had a discussion on probability sampling and non-probability sampling. Now, in this, we will be deciding about the sample size. What is the exact size of the sample we need for our area of research? How do we determine what is the ideal size of the sample? Now, the sample size determination is the act of choosing the number of observations or replicates to include in a statistical sample. Now, we all know what is the meaning of sample. So, sample means you are just choosing a few of the units of the entire population in order to collect the information. So, they represent the entire population. Now, how do you decide what is the number of people you need to just collect the information? That is what we mean by the sample size. The sample size is an important feature of any empirical study in which the goal is to make inferences about a population from a sample. In practice, the sample size used in a study is usually determined based on the cost, time, or convenience of collecting the data and the need for it to offer sufficient statistical power. Now, what are the factors which affect the sample size? So, the factors which affect the sample size is cost of collecting the sample, then what is the time involved in collecting, the convenience of collecting, and the need for it to offer sufficient statistical power. So, what is the statistical power it will give? So, all this will decide the sample size. Next, in complicated studies, there may be several different sample sizes. For example, in a stratified survey, there would be different sizes for each stratum. In a census, the data is sought for the entire population. Hence, the intended sample size is equal to the population. In experimental design, where a study may be divided into different treatment groups, there may be different sample sizes for each group. If it is a complex study what you are undergoing in the research, then we have to have the sample sizes will be based on different factors. So, what is this? So, in a stratified survey, so there will be different sizes for each stratum. What is the stratified survey? So, you divide the entire population into number of groups, and from each group you have a representation. So, from each group also you decide what is the number of people you have to select. So, that is what we mean by stratum. So, in a census, the data is sought for the entire population. Now, if you are having a census type of a survey, then what happens is you have to collect data from each and every unit of the population, and the sample size will be equal to the size of the population. And in experimental design, where a study may be divided. So, in case of an experiment, so you will be experimenting with various chemicals, and for that you will need different sample sizes for each group. So, you have a samples, so different samples will be there, and on each sample you experiment with the chemical. So, for each group there will be different sample sizes for each group. Then, next one, sample sizes may be chosen in several ways. The first one is using experience. Small samples, though sometimes unavoidable, can result in wide confidence level intervals and risk of errors in statistical hypothesis testing. So with the help, with the experience also, you can determine what will be the size of the sample. Now, sometimes if you are collecting a very small sample, suppose the population, that is the people you have to interview is almost 1 lakh, and then you decide that only I'll just interview only 10 persons and collect the sample, then the 10 persons will be representing the entire 1 lakh population. And then, so small samples, though sometimes unavoidable, can result in wide confidence intervals. That is, so whatever the information we are collecting from those 10 people, it may not be representative of the entire population, and the risk of errors in statistical hypothesis testing. So when we have a testing of the hypothesis, so we may encounter errors in that. Then, using a target variance for an estimate to be derived from the sample eventually obtained, that is of a high precision, is required. This translates to a low target variance of the estimator. Now, using a target variance for an estimate to be derived from the sample eventually obtained is of a high precision. Suppose you need to have a highly precise result from the research, whatever you are doing, then you should see that you should have a sizable amount of sample size. Then, using a target for the power of a statistical test to be applied once the sample is collected. So, once you collect the sample, then you just have to apply the statistical test and then see the variance and then decide what is the sample size. So, using a confidence level, that is, the larger the required confidence level, the larger the sample size. So, if you want to have a very good confidence level of the research, then better to have a larger sample size. Then, larger sample size generally lead to increased precision when estimating the unknown parameters. Now, we have the parameters of hypothesis. Now, when we have the parameters of hypothesis, so in order to just prove your point, it will be always better to have a large number of sample size. For example, if we wish to know the proportion of a certain species of fish that is infected with a pathogen, we would generally have a more precise estimate of this proportion if we sampled and examined 200 rather than 100 fish. So, as far as the sample size will be large, the results what we are getting will be more precise. So, several fundamental facts of mathematical statistics describe this phenomenon, including the law of large numbers and the central limit theorem. So, there are various statistical techniques which prove that the greater the number of samples, the more accurate the results will be. So, the law of large numbers and the central limit theorem, they all prove that the sample size, as it grows in number, the more precise results you will get. Then, in some situations, the increase in precision for a larger sample sizes is minimal or even non-existent. This can result from the presence of systematic errors or strong dependence in the data, or if the data follows a heavy-tailed distribution. So, in some cases, the increase in precision for larger size samples is minimal. Sometimes we feel that the large size samples, the precision rate is small or even non-existent. So, why do they say that? It is because of the systematic errors or the strong dependence on the data which is being collected. Then, sample sizes may be evaluated by the quality of the resulting estimates. For example, if a proportion being estimated, one may wish to have 95% confidence level interval be less than 0.06 units wide. Alternatively, sample size may be assessed based on the power of the hypothesis test. Now, the sample sizes may be evaluated by the quality of the resulting estimates. So, what is the estimate of the particular sample, and based on that you can decide the sample size. If a proportion is being estimated, one may wish to have 95% confidence interval. So now this confidence interval becomes very important in determination of the sample size. So if one wishes to have 95% confidence interval be less than 0.06 units wide, then the sample may be assessed based on the power of the hypothesis test. Now, if you don't have this confidence interval of less than 0.06, then you can always go in for the hypothesis test in the research. For example, if we are comparing the support for a certain political candidate among women with the support for that candidate among men, we may wish to have 80% power to detect a difference in the support levels of 0.04 units. So, if we are comparing the support of certain particular political candidate among women with the support for that candidate among men, we may wish to have 80% of the power to detect a difference in the support levels of 0.04 units. Then, the sample size is a research term used for defining the number of individuals included in a research study to represent a population. So, we all know that the sample size means it will be representing the number of units which you have included. The sample size references the total number of respondents included in a study, and the number is often broken down into subgroups by demographics such as age, gender and location, so that the total sample represents the entire population. So, the sample size references the total number of respondents included in the study. So, this size can be broken down further. So, how do you break down the sample size? So, it can be broken on the basis of age, gender and location, so that the sample represents the entire population. So, the entire population has equal representation on the basis of age, gender and location. Then, determining the appropriate sample size is one of the most important factors in statistical analysis. If the sample size is too small, it will not yield valid results or adequately represent the realities of population being studied. On the other hand, while larger sample sizes yield smaller margins of error and are more representative, a sample size that is too large may significantly increase the cost and time taken to conduct the research. So, while determining the sample size, we can say that a smaller sample size may give rise to a lot of errors, but then a larger sample size, there may be lot lesser errors. But then what happens is, when you have a too large sample, so that will increase the cost and time taken to conduct the research. Then next we will see what is this confidence interval and confidence level. So, as we have noted before, when selecting a sample, there are multiple factors that impact the reliability and validity of the results, including sampling and non-sampling errors. So, there are so many factors which will have an impact on the results. So, what are those factors? When thinking about the sample size, the two measures of errors that are always synonymous with sample sizes are confidence interval and confidence level. So, the two types of errors which we encounter when deciding the sample size is the confidence interval and the confidence level. So, if you can see here, the confidence interval is less than, plus or minus, and then we have this variance sign. So, here we have this. So, this middle part is the confidence interval. Now, what is this confidence interval, or what you call as the margin of error? So, confidence intervals measures the degree of uncertainty or certainty in a sampling method and how much uncertainty there is with any particular statistics. So, the confidence intervals, they measure the degree of uncertainty or certainty in a sampling method. So, in simple terms, The confidence interval tells you how confident you can be that the results from a study reflect what you would expect to find if it were possible to survey the entire population being studied. So, in other words, this confidence interval means, so it is the amount of confidence with which you can undertake research so that it will get the result whatever you have been expecting. So, you undertake research and you just expect that this will be the result, and then with the help of the samples you collect all the information and do the research. So that is what we mean by the confidence interval. Next, the confidence interval is usually a plus or a minus figure. For example, if your confidence interval is 6 and 60% of your sample picks an answer, then you can be confident that if you had asked the entire population, between 54% and 66% would have picked that answer. So, what do we mean by confidence interval? So, if it is always in a plus or a minus. So, confidence interval will be a positive or a negative number. Suppose your confidence interval is 6 and then 60% of the sample, they pick up the answer which you have expected. Then with the same confidence, you can also say that if you had asked the entire population, between 54% and 66% would have picked the same answer. Now the confidence interval means, now this is, suppose you have collected information from 60% of the population, then your confidence interval becomes 6. Now 60 minus 6, so that will be 54. Now 54% will be the lowest level and 60 plus 6, 66%, this will be the highest. So the confidence interval will lie between 54% and 66%. That is, if you had interviewed 54% of the population or if you had interviewed 66% of the population, they also would have given the same answer what you would have expected. So this interval between 54 to 66, so this we call it as the confidence interval. Next, what is this confidence level? So the confidence level refers to that percentage of the probability or certainty that the confidence interval would contain the true population parameter when you draw a random sample many times. So this confidence level is the percentage of probability or certainty that confidence interval would contain the true population parameter when you draw a random sample many times. It is expressed as a percentage and represents how often the percentage of the population who would pick up an answer lies within the confidence interval. Then, for example, a 99% confidence level means that you should repeat an experiment or survey over and over again. 99% of the time, your results will match the results you get from a population. So, if you have a confidence level of 99%, that means that you should repeat the survey again and again. So, 99% of the time, you will get the same results. Then, the larger your sample size, the more confidence you can be that the answers truly reflect the population. In other words, the larger your sample size for a given confidence level, the smaller your confidence interval. So, if you have a large sample size, then the confidence interval will be smaller. Next, we have the standard deviation. So, another critical measure when determining the sample size is the standard deviation, which measures a data set's distribution from its mean. So, we all know what is the mean. In statistics, we have studied. So, mean is sigma x divided by n. So, mean is the centralmost value of the given data. Now, what is standard deviation? Standard deviation will tell us the deviations from the mean. So, how far the given data is from the mean. So, in calculating the sample size, the standard deviation is useful in estimating how much the responses you receive will vary from each other and from the mean number, and the standard deviation of a sample can be used to approximate the standard deviation of a population. So, with the help of the standard deviation of a sample, you can also approximate the standard deviation of a population. The higher the distribution of variability, the greater the standard deviation and greater the magnitude of deviation. For example, once you have already sent out your survey, how much variance do you expect in your responses? That variation in responses is the standard deviation. So with this, we come to the end of this session. Hope you have all followed it. Thank you.